Alright, let's take a look. Calculate the concentration of hydronium ion, acetate ion, acetic acid, and hydroxide in a 1.44 molar solution of acetic acid. Now, to work this, you need to have looked up the Ka for acetic acid. If you haven't done that, you're going nowhere fast with this problem. Once you've done that, you really know what to do. You're going to use your ice chart. So, let's do an ice chart. We've got CH3, CO2H, have our water floating there, since water is a liquid and doesn't really partake in our equilibrium constant. And that's going to dissociate to form our acetate ion and our hydronium ion. Our initial concentration is 1.44 molar, and we assume that we have none of that. So our change is going to be minus x, plus x, and plus x. So an equilibrium concentration of 1.44 minus x, and x. So now we set up that equilibrium expression, of course. Products over reactants so 1.8 times 10 to the negative fifth equals x times x over 1.44 minus x and what I'm going to do is it looks like I have low values here. So I'm going to check and see if I can make the assumption that 100 times 1.8 times 10 to the negative fifth is less than 1.44. And it is. So I can rewrite my equilibrium expression now much easier. 1.8 times 10 to the negative fifth simply equals x squared over 1.44, which means that I have an x value of 8 second EE negative 5 times 1.44 second square rooted (5.09 times 10 to the negative third molarity is my x value. So we come back up to our chart, and we've now got 3 of our concentrations. I've got my concentration of acetic acid, 5.09 times 10 to the negative third, and my concentration of hydronium, 5.09 times 10 to the negative third. And then I'm going to subtract it from my 1.44. And when I do that, I get 1.43 for my acetic acid concentration. So now I just have my hydronium ion concentration. Remember, 10 to the negative 14th equals the concentration of hydroxide times hydronium. So my hydroxide ion concentration is equal to 10 to the negative 14th divided by my hydronium ion concentration. So my hydroxide concentration is 10 to the negative 14th divided by 5.09 times 10 to the negative 3rd equals 1.96 times 10 to the negative 12th molar. So that's my hydroxide ion concentration, and those are my other concentrations. And that's how you work that one. Beep.